Yeah, thanks so much. It's such a great pleasure to be here, and thanks to Professor Acharya for having invited me, and great to meet Vegard and Professor Malhotra, and I guess that's your faculty here, and good to meet you. I believe this is the first batch of MA in Public Policy. So as Professor Acharya just mentioned, I'm a trained economist, but I didn't come into economics right away. I first worked in the government. Like many people who come into economics, we think economics has a lot to do with the real world and real world problems, and that's somehow what attracts us to economics. I was in the Indian Economic Service, which is, I think, the service to which Professor Malhotra also belongs. So I worked there, and then I went to get my PhD. And I have had this very interesting oscillation between policy and academics. So I started at the World Bank, but then came back to research, but then jumped back into running the National Institute of Urban Affairs for a year, which was in the rank of Additional Secretary in Government of India. And then most recently, I was at the Lee Kuan Yew School as a full-time faculty, now as an adjunct. So the Lee Kuan Yew School of Public Policy. And it's a big challenge when you're in public policy because you have to have academic rigor and publish in refereed journals, but at the same time, not so much with a young cohort like this, but you get mid-career civil servants. And when you're actually teaching economics or some such thing to mid-career officers, it's a big challenge. You have to make it very relevant and applied. So it's a very interesting kind of a mix. So I'm not as pure an academic as some of my colleagues at D School who have the luxury of being entirely in the world of theory. So all of this sort of informs the kind of work I do. And I've lately been a lot in climate change. And this paper that I'm presenting is in that vein. We've been looking at some of these issues. I do a lot of work with IPCC, the Intergovernmental Panel on Climate Change, which is a very prominent UN-supported body. So without further ado, let me get into this paper. Let me tell you the motivation for this paper. The motivation for this paper was that Partha Sen, a good friend and till recently a colleague at D School, Delhi School of Economics, which we call D School. So we talked about it. We organized a roundtable on climate change and the Indian economy. And we were thinking that, look, climate change at a very aggregative level, at the Indian level, is one thing, but at the regional level, the impacts may be quite differentiated. So the idea is some states could be more impacted by climate change than other states. And we have in India a big concern about inequality of various sorts. We think about interpersonal inequality, we measure poverty, we do all this. We're very concerned with equity, and there's also an interstate concern or a regional concern about equity through the Finance Commission. We try to allocate and even things out. So the motivation was that how would climate change impact on interstate differences? Could it exacerbate things? So there is a literature there, and we started speaking to that, but then we got down to very nitty-gritty of real data, and we kind of then ended up writing a paper on sort of looking at district level impacts and yields, which I will just describe. How much time do I have?
Oh, until 4:30.
Oh, to 4:30. Okay, great. So what about speak for an hour and then discussion, or this free form?
It could be slightly less speaking, more questions, but 1 hour, yeah, 1 hour is fine.
Or I can do about, it's 3:10, so is 4 okay?
Yeah, 4, yes.
Okay. I'll probably finish earlier. Okay, so you have the structure of my talk, the main results, and also just to tell you a little bit about where the paper is. Like I mentioned, in September 2011, the Delhi School of Economics, in partnership with the Ministry of Finance, Government of India, organized a roundtable on climate change in the Indian economy, which was also supported by DFID, the Department for International Development of the UK. And it was a very successful event. It was an event only by invitation. we had a lot of very key policy makers. Because when you think of climate change, which is in popular jargon called global warming, usually you speak to the people who work in the profession. So typically you would have all the people, you know, Professor Pachauri or Dr. Pachauri, and, you know, I mean, there's a tribe. We wanted to mainstream climate. We wanted to say, okay, how do the macro policy people in the country see climate change as impacting on India's growth and inflation and so on. So we, in partnership with the ministry, were able to get a different set of people around the table. We had the Deputy Governor of the Reserve Bank, Subir Gokarn. We had the Chief Economic Advisor, Kaushik Basu. We had the Secretary Economic Affairs, Mr. Gopalan. We had all these people who were not thinking of climate in a day-to-day basis, but thinking of management of the Indian economy. So we did this, and then we eventually commissioned 3 papers, which by coincidence all happened to be on the impact of climate change on Indian agriculture. And these are now coming out as a symposium in a journal called Climate Change Economics, edited by Robert Mendelsohn at Yale University. So I'm happy to tell you that this paper of ours is one of the 3 and is under submission, revise and resubmit as it's called, and with good comments. So I think we're very happy that this will come out as a symposium on climate change in Indian agriculture in a pretty good journal, I would say. So, and we also have the Social Science Research Network, SSRN, and this has just become a top 10 download, about 20 odd downloads in the SSRN. So that's the basic idea. So I'll tell you a little bit about the conclusions or the summary of our paper right away. I'll describe the climate features and trends for India, give you some background on food grains, and then get into the literature, the data, the methodology, and our results. And then tell you a little bit about climate scenarios and how that would impact on yield. So here's sort of a bottom line of what the paper is trying to do. We are trying to estimate the impact of climate change, which, as I mentioned, the journalistic term is global warming, but the more precise term is climate change, because climate change is not just warming of the planet, it's also other changes in the climate system, such as more frequent extreme weather events, big droughts, big floods, hurricanes. It's also sea level rise, and it's also a bunch of other things. So we are looking at the impact of that on key food grains in India, and we are looking at 3 crops. Rice, we are looking at millets, which in India the 2 big millets are jowar and bajra, which are basically sorghum and pearl millet. And then what we are really doing in this paper is fairly straightforward. What we're doing is we're estimating crop-specific agricultural production functions. And we have controls on the right-hand side for inputs such as irrigation, fertilizer, and labor. And then we have exogenous climate variables such as precipitation and temperature. And the important thing that we are doing in this paper is that our analysis is at the district level. Much of the analysis of the work on climate in India is often done at the national level, which is somewhat meaningless if you think about it. It's a huge country with huge variation in topography, physical features, regions, etc., etc. I mean, it's just too big a country to be aggregative, which is where I think the problem with a lot of the climate modeling arises. And even at the state level, I would argue that it's quite not so useful. States in India could be bigger than countries in Europe. Not could be, are. So again, thinking of a state level variable is kind of, so I think the more disaggregated you can make your analysis, of course, subject to data availability, I think the more meaningful it is. And as I started motivating this talk by talking about regional variations, there are winners and losers. There's a lot of nuance, certain parts of the country may do better, some may do worse. And then from a policy level, that has huge implications for inter-regional equity, and should then the state, meaning the government, do something about evening the playing field, and which is what we are very concerned about. And that's why we have the Finance Commission, that's why we have all these concerns about these distributive programs. So our analysis is at the district level. We use a panel data set, cross-section over time, and we basically, our key variable is output per hectare for these 3 crops, and the period we have is till 2000 roughly. We are now trying to extend this data to more recent years, but we have captured a sort of a big, I would say roughly like a 40-year slice. And to just give you a preview of our results, we find consistent with other studies. There are 2 or 3 studies that I will describe very quickly, which also find a significant impact of climate change on yields for India. That is okay. So, and also just another remark in terms of preamble, which is not in the slides, is that looking at the impact of climate change on agriculture is a fairly obvious thing to do, because unlike other sectors of the economy, think of industry, there would be indirect impacts of climate change. But agriculture is obviously a very, intuitively a very obvious area where variations in weather and climate are going to impact on output. Because in a sense, weather variables are very directly relevant. So you could, for example, think of climate and weather impacting on human health, which could then impact on productivity. So you can think of indirect channels. But here, what you could say is that agriculture is a direct, climate or weather is a direct input into a production function. And this is not just for India. Even if you think of advanced economies like the US, there have been some excellent studies done, which I am not reporting here, which have actually found major impacts of climate change on US agriculture. Now, the share of US agriculture in the US economy is obviously not very big in relative terms, but in absolute terms, it's very big. America is still a very big producer and a big sort of an exporter, America, Canada, etc. So what's happening to their agriculture is of great interest to policymakers there. And broadly, 3 approaches are used to look at the impact of agriculture on climate change or climate change on agriculture. One is the one we have done. We're looking at actual data. The second is what agricultural scientists do, which is they look at experimental data. So it's more like a lab where you can take a particular plot of land, you can then control or vary some inputs like temperature and rainfall and see what is happening on the effect on yields. It's a little bit like what you would do in a chemistry lab or something like that. The critique of that approach is that it doesn't allow for adaptation. A farmer is not passive when the weather changes. He may plant late. If the rains are coming late, he may plant late. He may compensate by using other inputs more aggressively. If the rains fail, if he has the ability, he may use more water, from other sources. He may actually use less inputs. So if the rains are failing, he may not use expensive inputs like fertilizer, right? So there is something called adaptation. A crop, a kind of an experimental data doesn't capture that. So no surprise that experimental data doesn't show big impacts of climate change. So there is a whole literature out there which is debating which is the right way to look at the impact of climate change on agriculture. And I'm simply mentioning this to tell you that our approach is very much in a sort of a data-driven approach. We look at actual data. We look at how climate could have impacted on agricultural yields. And then we make projections about, well, okay, if these are the trends in temperature and rainfall, what's going to happen to yields. India's climate is somewhat unique. This is a problem when you look at regional and global climate models, which are at a high level of aggregation. Typically, a model would have a 300 by 300 kilometer resolution. Global climate models miss out key features of a topography, such as the western and eastern Ghats and so on. We in India know that our climate is dominated by the monsoon, which is called the southwest monsoon. And it accounts for about 80% of our rainfall. Much of our rain comes roughly in that period of June to September, when we are all anxiously watching the progress of the monsoon. And just from a policy perspective, our current president, our former finance minister, kind of, I wouldn't say facetiously, but in a way very practically said that the rain is the real finance minister of India, in terms of... so Shubir Gokarn, the deputy governor of the Reserve Bank, when he came to a round table, he gave an... because people ask, what's the central bank deputy governor doing in a climate event? And he had a brilliant talk where he said, climate change, why should central banks care? And again, just as an aside, I think that, a lot of food inflation that happened, which may have led to more systemic inflation in our country, is probably stemmed from some weather-induced effects. And the third paper of our symposium is looking at that. That's being co-authored by my colleagues at D School. So the basic idea is that our climate system is fairly unique. It's not well captured by global models. And the monsoon is not that well understood, to be very honest. But it is still a very important phenomenon in our country. It is a very important it's economically a very important weather pattern. And almost if you look at this chart, the growth rate of our agricultural production, agricultural output and the monsoon are almost very closely tracking. They march in lockstep. And this seems very puzzling. You'd say, well, India is now an advanced country. We make computers and whatnot. And, we have a lot of irrigation in our country and we've been at it for the last 60 years. But, the data is that even today, or till recently, about 140 million hectares in India are rain-fed. And or rather of the 140 million hectares, 85 million hectares are rain-fed, and this is spread over 177 districts. So, a big chunk of our country is still rain-dependent. And in climatically, we call this the semi-arid tropics, which covers a large part of our country, and a lot of very poor people are being impacted. What are the climate trends for India? To put it in a nutshell, India is going to be warmer and wetter as far near-term projections are concerned, but wetter in a very... That's the mean of the distribution, right? If you look at the higher moments of the distribution in terms of the variability, you'll see that the rain is going to be more erratic, to put it in a nutshell. We'll have a decrease in the number of rainy days by more than 15 days. But when the rain comes, it'll be more intense. So the increase in the intensity of the rainfall would go up by 1 to 4 millimeters per day. There's been some excellent work done by the Ministry of Environment through a network of scientific institutions, which is doing these medium term. So 2030 is about 20 odd years from now. We will find India becoming warmer and wetter, but that's on the whole. We will have, as I say at the bottom of this slide, very significant regional variation, which is again a plug for doing very disaggregated work and not just looking at the country as a whole. If you look at our temperature trends, India is warming, which is consistent with overall warming trends in the world. And there is an inflection in this trend. So over the last 40 years, the warming has increased. So you can say it's getting warmer at a faster rate. And both the mean and the max and the min temperatures. So the entire distribution is kind of shifting to the right, if you will. So those are some of the broad trends that we are observing in our temperature. Why are we still concerned about agriculture? You could obviously make the case that agriculture only accounts for 15% of our national income, roughly, excluding forestry and fisheries. So why is agriculture important? Because it still accounts for 55% of our labor force. And it has important forward and backward linkages to the rest of the economy. So it's not such a trivial topic. And to put it in perspective, manufacturing in our country is not that big either as a fraction of national income. And one would put the number at something like 20 odd percent, maybe 25%. So relatively speaking, it's because we do know in our economy, services is very large. Rice is a very important crop, as we all know. And it's the highest value of all products, agricultural products in India. So it's a very important crop to look at. Millets are obviously not that important in terms of either value of output or share of output, but they are traditional what we call coarse cereals. So we have jowar, bajra, and we have maize, that is corn, and then of course, so these are coarse cereals, and these are somewhat more staple consumed by the relatively poorer parts of our population. So we, by choice, looked at millets and we looked at rice. We have not looked at wheat. There are some other studies I'm citing that have looked at wheat yields. Our own view is that wheat is very problematic because the wheat market is very distorted in terms of deep government intervention in procurement, in various other things, less so in rice. So we have kind of hesitated from looking at wheat, at least for now. And this was, of course, our first stab at this kind of work. But I don't think that wheat is very complex. So we could discuss this, and I'd be happy to take questions of why we haven't picked up wheat in our analysis. Just to give you a very quick overview of what, because for me too, it was a big learning curve to get into this topic. I don't normally work on ag. So there are 3 seasons for growing rice, but the big rice is our winter rice. The season is when the rice is harvested. So winter rice means that is the crop that's harvested in winter. We call it kharif. So it's usually harvested, it was just recently harvested, more or less, because there are regional variations, and that accounts for the bulk of the rice grown. And obviously this is coterminous with a monsoon. So large parts of the country still would have rain-fed rice. And on the other hand, when you look at millets, there are 2 key millets, which is bajra, pearl millet, and sorghum, jowar. And the key thing about millets is that they're very hardy, as we would intuitively believe or know. They are tolerant to very difficult growing conditions. They can grow in very low fertility soils. They can take very high temperatures, and they can grow in areas where rice and wheat, particularly the genetically modified rice and wheat, the high yielding varieties of rice and wheat, are very sensitive. Wheat is particularly sensitive to temperature. We haven't modeled wheat, as I've already said, and rice too, at least the more recent types of rice. So the policy implication of this is that, so just giving you some sense of where millets are grown and all. I'll skip some of these details. I think we should move on. I want to just highlight this particular picture for you, because obviously this talk is at a public policy school, and so it has to have a policy kind of a twist. And again, the paper that we're trying to sell now to the journals is from a policy perspective. What's very interesting of the graph you see on the top left is that if you go back to the 60s, the green revolution was about to start, millets were actually they were quite important. They were more important than wheat in terms of total output. Rice was of course there, but as you can see, millets have stayed flat, whereas wheat has really shot up, and so has rice. And if you look at the bottom right, and if you look at that picture, that's the area under millets. So the area under millets has declined. The area under rice has more or less stayed the same. The wheat has also gone up. So obviously there have been major productivity or yield increases in rice and wheat, and this is something that we all know, but it's still good to remind ourselves of what we were 40 years ago and where we are. And again, it's of course easy to second guess, but in a sense, a kind of a implication that's coming out of our work is that the conscious focus on rice and wheat for various reasons of food security, etc. And if you couple that with findings, not just ours, but global findings that wheat is very susceptible to climate change, and so is to some extent rice, is trying to say that this strategy has made us kind of more vulnerable to climate change, had we then, thought of millets. And there are other, of course, nutritional advantages of millets and so on. So in a sense, what we did, the path we went down at that point of time, the decisions we made, have had some unintended consequences, not just environmental consequences about which now a lot is being written. The groundwater contamination, the salinity of the soil, and that the green revolution has come with very huge environmental costs and is probably not sustainable. So it has bought us time, it has got us food security, but it has had all those. So those are very legitimate critiques. And we are adding another dimension to it, saying that, look, you may have actually increased the vulnerability of Indian agriculture to climate change by betting on rice and wheat as compared to a crop that is much more resistant. The literature on agricultural production starts, there was, if you do ag, you'll see there was this big interest in supply response. Supply response is a simple way of saying, is there a supply curve? So when you have a supply curve, you know that a higher price means more supply. So the initial sort of literature was not really a production function type literature, but it was more saying, okay, if farmers have more, if you give them a higher price, would they supply more wheat, rice, whatever? So the Lahiri and Roy Journal of Development Economics is a supply response, but when you look at supply response, you look at policy variables like prices, but you also look at controls such as weather, rainfall. So Lahiri and Roy obviously found that rainfall has a big impact on supply, and they modeled rainfall as a gamma distribution, which is a right-skewed, zero-bounded, single-tailed kind of a distribution. And they had a very interesting finding in the paper, which I have reported here, which is that with the spread of high-yielding varieties, the Green Revolution, Indian agriculture was actually more dependent on rainfall, which seems very paradoxical, but because the water requirement goes up with the HYV, and the spread of irrigation has not kept up with it. So this was a kind of a paradox, but this was flagged in that paper. Lately, people don't read this paper so much, but I think this is a very important contribution. And then a colleague of mine, Sunil Kanwar, did some work at the state level. There has been a very recent paper by Maximilian Offhammer of Berkeley, along with Jeff Vincent, some very big names, who have extended this kind of work. So Lahiri Roy was all India, and there have been some other works like this, but that's a good one. Then state level panel data sets have happened, and they have again found that rainfall matters quite a bit. The problem, as I've already flagged for you, is that lots of Indian states are very big. Now, if you're going to run a regression with, say, state level output or yield per hectare on the left-hand side, and you have rainfall or other variables on the right-hand side, those have to be, again, a kind of a aggregate state level. So, as I have said, the problem here is you have to need to aggregate this data to one value at the state or the national level. And I think that's clearly problematic. So I think a big contribution of work like the one that we have done is to look at district level. So I would again say that's a considerable step forward. But of course, Gutierrez does the same thing. Gutierrez, this is actually a PhD out of MIT, and Gutierrez is now a tenure track assistant professor at Maryland. He looks at temperature and rainfall and 5 major crops, food crops and cash crop. But the problem with Gutierrez is that he combines all this on the left-hand side. So he has got more something like a district domestic product. So he monetizes and he combines and sticks them all in the left-hand side, and I think that's again quite a problem. So the two papers I think that are very close to what we have done using district level panel Fishman and Krishnamurthy. So as you can see, this area is still very active in research. So it's not as if there's a lot out there, and we summarize the 3 district level analyses that have happened. And as you can intuitively guess, all of them find negative impacts of temperature and positive impacts of rainfall. And the interesting thing is that, to again give you a preview of the results, the temperature effects kind of wash out the rainfall effects. That's really what's happening. Though more rainfall on the whole is good, more temperature on the whole is bad, and the magnitude of the coefficients is such that the temperature effects would swamp the rainfall effects. So that's kind of What do? We use, as I said, panel data, our dependent variables. So we do crop specific production functions. We are not like Gitter by ratio of area under crop to the gross cropped area of that district. So if a crop, if say rice accounts for 30% of the total output, sorry, not the output, the area. If the 30% of the gross cropped area of a particular district is under rice, then we make an assumption that 30% of the fertilizer is used on that. So that is obviously an imperfect approximation, but since the other working hypothesis could be that we could take the value of output, but then we need to have prices, and then there are issues with prices since there are all kinds of distortions and interventions in the markets. So we have done that, and then we have done the same apportionment for labor.